A resultant force acting on a stationary, movable object will cause the object to gain momentum. Remember that by a resultant force, we mean when the forces acting on an object aren't balanced and we express their overall effect as a single force. Here we have a stationary billiard ball. Let's suppose we then hit it with a pool cue. As the pool cue makes contact with the ball, a force is applied from the cue to the ball. As a result, the ball starts moving, as we'd expect from Newton's first law. The momentum of an object is a product of its mass and its velocity. So since the ball has gained velocity, it's also gained momentum. We also know that the total momentum in a system cannot change. Remember that by Newton's third law, there will be an equal and opposite reaction force from the ball to the cue, causing the cue to lose as much momentum as the ball has gained. Now let's see what happens when we have a resultant force on an object that's already moving. A resultant force acting on a moving object will result in a change in its momentum. So let's look at two examples of this. On the left, we have a skydiver who's just opened their parachute. They were originally falling downwards, which means they have a downward momentum. Then their parachute causes a drag force, which slows them down. As their speed is decreasing, they are losing momentum. The change in momentum caused by the parachute opening helps them to land safely. On the right, we have a satellite that's orbiting Earth. During its motion, it's being acted upon by gravity. This force doesn't change the satellite's speed, but it does cause it to change direction during its orbit. Remember that momentum is a vector, meaning it has both magnitude and direction. If an object's direction of motion changes, then its momentum must also change. This changing direction example won't come up in your exams, but it's helpful for understanding the link between forces and momentum in more detail. You could be asked to explain how simpler examples like parachuting show a force causing a change in momentum though. Now let's look at what determines how much momentum will change. The change in momentum increases if the force is stronger or applied for a longer time. Let's look at an example of a car slowing down. It does so by applying a braking force. This resultant force causes a change in momentum. Specifically, the car loses momentum as this force is directed opposite to its motion. Now, how can we increase the amount of momentum lost? Well, firstly, we could use stronger brakes in the car. Doing so will lead to a stronger braking force and increase the amount of deceleration. Hence, the car loses momentum more quickly. Alternatively, we could apply the brakes for longer. This means the braking force is applied for longer, and so the deceleration lasts longer. As a result, we lose more momentum overall. We can use either of these methods to increase the amount of momentum lost. You don't need to recall this exact example in your exam, but you should be able to analyse given examples to explain how forces cause changes of momentum and how to increase this change.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!